Hello everyone, I am Divyoti lecturer in physics. In this video tutorial, I am going to explain you how image form in a plane mirror, what is spherical mirror, its type, some term associated with spherical mirror and sign convention. Okay, so let's begin. First one, formation of image in a plane mirror. You see this diagram. Concentrate on this diagram. Okay, let's consider a source S at a certain distance from the mirror xy. Xy is the mirror. A ray of light SA incident normally I equal to 0 and reflected back as AS R equal to 0. Okay, so S is the source. We have taken a ray of light SA which is incident normally to the mirror xy as I equal to 0. That's why according to law of reflection R equal also 0, so it's reflected back in the same path, in the opposite path. Okay, not in the same path, in the opposite path. Okay, so let's consider another ray of light as O, incident at the incident angle I and reflected along OI with a reflected angle R. Okay, so SO is the incident light which is incident obliquely with an incident angle I to the plane mirror. Then after incident, it got reflected with an angle of reflection or reflected angle R. Okay, so both rays are going upward, so they don't meet in that direction in any way. There is no chance of meeting after two rays AS and OI in the upward direction because they are going in separate direction. Okay, in order to produce image, the ray AS and OI need to be back produced so that they will converge at a certain point, and at that point when the two rays converged, the image will form. Okay, so AI is the back produce of ray AS and OI is the back produce of ray OI. So the two back produce of ray AS and OI is meeting at point IDEX, or we can say they are converging at point IDEX. So IDEX is the image of the source S. Okay, let's see what is the behavior of image. See, in between see, the ray AS and normal are parallel to each other, so the angle ASO equal to the angle SON. The angle ASO equal to the angle SON. The angle ASO equal to the angle SON equal to I, alternate angle. Okay, then the angle AITEX-O equal to angle NOI equal to R, corresponding angles. See, the angle AI takes O equal to the angle NOI equal to R because they are corresponding angle. Okay, but according to law of reflection, we know I equal to R. That's why the angle ASO equal to the angle AI takes O. Now compare the triangle ASO and AI takes O. Okay, in between the two triangle, AO is the common. The angle ASO, the angle ASO equal to the angle AI takes O. We got it previously. Both are equal, and the angle SAO, the angle SAO equal to the angle I dash AO equal to 90 degree. Okay, so the triangle ASO and the triangle AI dash O are congruent. Okay, so what is the result? AS equal to AI dash. That means the image IDEX lies as much as behind the mirror, as much object in front of it. So, okay, what are the characteristics of the image formed in a plane mirror? Okay, the image is virtual. The image and mirror are lies at the same distance from the mirror. Okay, the image and the object lies at the same distance from the mirror. The third one, both the object and image are of same size. Fourth one, the image formed is laterally inverted. Means you see your left side each on right side in the mirror and your right side each on left side of the mirror. Okay, this property is called laterally inversion. Okay, then we will learn about spherical mirror. So let's begin. A spherical mirror is a reflecting surface which forms a part of hollow sphere. That means जो spherical mirror है वो hollow sphere का एक part होता है. Okay, let's consider a hollow sphere as shown in the picture. Let's this hollow sphere is caught by plane AB, then the section APB forms the part of hollow sphere and it is called a spherical mirror. Okay, so spherical mirror are of two types. One is concave mirror, another one is convex mirror. So concave mirror. Concave mirror is a spherical mirror in which the outer ball surface is silver coated and the reflection of light takes place from the inner hollow surface. See, this is the outer wall surface, this is the inner hollow surface. The outer surface is silver coated. The outer surface is silver coated and the reflection of light takes place from this inner surface. Okay, this inner surface. And what is convex mirror? Convex mirror also a spherical mirror. In this mirror, the reflection of light takes place from the outer wall surface and the inner hollow surface. Okay, the inner hollow surface is silver coated. Then terms associated with spherical mirror. There are different terms like pole, focus, center of curvature, radius of curvature, angular aperture, linear aperture, principal axis. These are different terms which you need in future. While we get to know details about spherical mirror, while we will derive some derivation, these terms are needed. Okay, first one, pole. The pole of spherical mirror is the center or middle point of a spherical mirror it is represented by letter P. So let's see what is pole and where it is situated. The section A, P, B is called the spherical mirror. Okay. Then, as per definition, the pole is the center or middle point of the spherical mirror. This is P. This is pole. This is the middle point of the spherical mirror, and it is represented by P. Then, center of curvature. It is the center C of the hollow sphere of which the mirror is a part. Look, this is the hollow sphere. This is the center of curvature. Okay, this is the center of hollow sphere only. Okay, from which the mirror is a part. Then radius of curvature. It is the radius of hollow sphere of which the mirror is a part. In other words, it is the distance between the center of curvature and the pole of a mirror. It is represented by letter R. Okay. Radius of curvature is the center of the hollow sphere from which the mirror is a part. Okay. Then we can also say it is the distance between the center of curvature. This is the center of curvature C and the pole. Center of curvature C and pole. That is called radius of curvature. The distance between the center of curvature and the pole is called radius of curvature, which is represented by letter R. Then principal axis. It is the line PC passing through the center of curvature and its pole. In other words, it is the line joining the pole and center of curvature of a mirror. This is the principal axis. Look, this line passing through 2 points. Okay, C and P. C is the center of curvature, P is the pole. Any line passing through the center of curvature and pole is called principal axis. Then linear aperture. It is the diameter AB of the circular boundary of the spherical mirror. This is the spherical mirror APB. AB is the diameter of the spherical mirror. Okay. The AB is called what? Linear aperture. Then angular aperture. It is the angle ACB subtended by the boundary of the spherical mirror. Looks, boundary means A point, B point. This is the boundary. This is the angle ACB. ACB means this angle. The angle ACB subtended by the spherical mirror is called angular aperture. Then principal focus. A narrow beam of light parallel to the principal axis either actually converges to or appears to diverge from a point F on the principal axis after reflection from the spherical mirror. This point is called principal focus of the mirror. So, in order to understand what is principal focus, let's see these two diagrams. Okay, this diagram and this diagram. Look at the first diagram. This is a concave mirror. A beam of light are passing parallel to the principal axis. This is the principal axis. This is the principal axis. Okay, principal axis passing through the point C and P. Okay, beam of light passing parallel to the principal axis. In this case, it appears that the total beam of light R appears to converge at some point F. Okay, so this is principal focus for a concave mirror. In the figure B, it is a convex mirror. We see that the beam of light which are passing parallel to the principal axis gets divert gets diverged gets diverged from some point F after reflection. Okay, so this point F is called principal focus for convex mirror. So in case of concave mirror, the lights or the beam of lights are converged at some point, okay, which called the principal focus. And for convex mirror, it appears that the total beam of light which passing parallel to the principal axis are diverted from some point. Okay, the point is called principal focus for convex mirror. Then focal length. It is the distance between the focus and pole of the mirror, and it is represented by small f. Okay, distance between focus and pole. Focus means principal focus. This is the focus, and this is the pole. The distance between the focus or principal focus and pole is called what? Focal length. Then focal plane. A focal plane is a virtual plane passing through the principal focus and perpendicular to the principal axis. Look, this plane, this plane, this plane. Okay, this this plane. Okay, this plane is passing through what? The principal focus. Okay, passing through the principal focus, and this is perpendicular to the principal axis. This is the principal axis. This is perpendicular to the principal axis. Okay, so a plane passing through the principal focus and perpendicular to the principal axis is called focal plane. Okay, then some note. This is a note. You need to know about some notes. Okay, a line joining any point of a spherical mirror to the center of curvature is always normal to the mirror at that point. So a line joining any point on the spherical mirror. A line joining any point. Suppose this is the point. Suppose this is the point. Okay, or this point, or this point, or this point, any point on the spherical mirror and center of curvature and center of curvature. Okay, any line joining any point on the spherical mirror and the center of curvature is perpendicular to the mirror at that point. Always any line joining any point on the spherical mirror and the center of curvature always perpendicular to the spherical mirror at that particular point. Okay, so then sign convention. Okay, while handling derivation in optics, we have to deal with measurement of certain distance like distance of object small u, distance of image small v, focal length small f. I have told you before, focal length it is represented by small f, radius of curvature capital R. Okay, so डेरिवेशन हम करते हैं ऑप्टिक्स में, डिफरेंट डेरिवेशन है, देन वी विल डील्स अबाउट डिफरेंट प्रॉब्लम. So before jump into derivation or problem, we have to know about what are the sign of different distance. Okay, that's maybe positive or negative. So what are the rule? The first rule, all ray diagrams are drawn with the incident light traveling from left to right. Always remember, रे डायग्राम जब हम रे डायग्राम ड्रा करते हैं, इंसिडेंट लाइट ऑलवेज हम स्टार्ट करेंगे फ्रॉम लेफ्ट हैंड से. ओके, लेफ्ट हैंड से राइट हैंड को जाएगा, लेफ्ट हैंड साइड से राइट हैंड साइड को जाएगा. जो रे है ऑलवेज ट्रैवल फ्रॉम लेफ्ट हैंड साइड टू राइट हैंड साइड. देन सेकेंड वन, all distances measured from the pole of the mirror. Any distance always measure from the pole of mirror. डिस्टेंस ऑलवेज मेजर फ्रॉम द पोल ऑफ मिरर. को हाँ कहीं पे भी हम डिस्टेंस ले लेंगे तो वो डिस्टेंस हम सिर्फ और सिर्फ पोल से मेजर करेंगे. ओके, लेट्स दिस इज ए पॉइंट एक्स. अगर इसके भी हम डिस्टेंस मेजर करेंगे तो यहाँ से ही मेजर करेंगे, ना कि यहाँ से. ठीक है, यहाँ से ही मेजर करेंगे. देन all distance measured in the direction of incident light is taken as positive. So distance measured from the pole of the mirror, we measure distance from pole of mirror. If the distance measured in the direction of incident light, then it will taken as positive. Let's in this point, the distance is measured from the pole of mirror. This is pole of mirror. Okay, from here we will measure only the distance. This distance. Let's this distance is a. So what is the sign of a? So this distance is measured from P to X, and P to X is the direction of incident light. So A is positive in sign. If we measure certain distance Y, okay, so distance Y from the pole of mirror, then the distance between P and Y always measure from the pole. पोल से ही मेजर करेंगे. सो जब पोल से मेजर करेंगे हम P से y डायरेक्शन में जाएंगे. सो P से y डायरेक्शन मीन्स डिस्टेंस against the incident light, that's mean it is negative, which is the fourth law. All distance measured in the direction opposite to the incident light is taken as negative. Okay, all transverse measurement done above the principal axis is positive and below the principal axis is negative, like this. This is the transverse displacement. Okay, all transverse measurement measure above principal axis is positive and below principal axis is negative. Okay, so according to sign convention, the focal length and the radius of curvature are negative for a concave mirror and positive for a convex mirror. ठीक है, जो रेडियस ऑफ कर्वेचर और फोकल लेंथ है कॉन्केव मिरर का, वो नेगेटिव साइन है, और फॉर कॉन्वेक्स मिरर द रेडियस ऑफ कर्वेचर एंड फोकल लेंथ आर ऑफ पॉजिटिव साइन. ओके, so we've got idea about what is a spherical mirror, what are different type of spherical mirror, what are the terms related up with spherical mirror, and sign convention. So learn about this thing. I will explain details during the VC. Okay, thank you.